So today we have a problem from legendary magazine Komal. To determine the coefficient of friction between cylinder and the surface of an inclined plane, let's write down the equilibrium condition for the body. The condition for equilibrium is that the vector sum of all forces acting on the body must be zero. Let's depict all the forces acting on a cylinder. The force of gravity acts from the Earth's side. It's applied at the center of mass and directed vertically downward. From the surface, two forces act on the cylinder: the static friction force and the normal reaction force. This force is applied at the point of contact between the cylinder and the surface. Additionally, the tension force of the string or the reaction force of the string acts on the cylinder. Its point of application is the point where the string is attached to the cylinder. To solve this problem, we can use the equilibrium condition, but I suggest to use the theorem of three forces or theorem of Lamy instead. So let's try it. You can notice that we need three forces to use theorem of three forces, but four forces act on our body. But we can combine two of them into one. This way we'll have three forces, and we probably combine the friction force and the normal reaction force to get the total reaction force, which we can denote it by the letter Q. Lamy's theorem states that if three non-parallel forces act on a body, their lines of action must intersect in a single point. According to the theorem, our forces must intersect at one point, and this point will be the vertex on the cylinder where the string is attached. Now, let's determine the angle between the reaction force and the vertical. To do this, we'll start by analyzing the angles. We have an angle of 60 degrees. Now this angle will also be 60 degrees. Next, this angle is 30 degrees. This angle is central angle of the circle and subtend the specific arc. The same arc is subtended by an inscribed angle, which is half of measure of the central angle. Therefore, this angle is 15 degrees. So the angle between the inclined plane and the reaction force will be 75 degrees. I found it by subtracting 15 degrees from 90 degrees. Now let's recall what static friction is. Static friction force acts on a body when the relative velocity on the contact point is zero. Static friction force lies within a certain range. If we now draw a triangle of forces, we will see that the ratio of the friction force to the reaction force will be equal to the cotangent of this angle. The resulting value of the friction coefficient will be the minimum value of the friction coefficient. So finally, I can say that problems like this help you build a rock-solid foundation in physics. You're dealing with forces, equilibrium, friction, and even some geometry. These are core concepts that show up everywhere in physics, from mechanics to engineering. If you like this video, don't forget to like and subscribe to the channel. I also have a Telegram channel that you can subscribe to. There is a lot of interesting material and tasks for training for the physics competition. Thank you for watching. See you next time.